Okay, now let us talk about limits at infinity and relate to the horizontal asymptotes. Okay, so now last time we talked about if I have the limit x approaching to a of f of x equal to infinity or negative infinity. Okay, so in this case we will have the vertical asymptotes at x equal to a, right? Superscript positive or negative. Okay, doesn't matter. Okay. Then now let us look at this one right here. Okay, this is a little bit different. We will have a limit x approaching to infinity. Okay, so this is different. To the last section, we have x approaching to a number. However, this section right here approaching to infinity or negative infinity. Okay. However, what happened to the output is a number. Okay. So if I have the limit x approaching to infinity of f of x equal to L, a number. So in this case, let us look at the graph. So it means that when x is getting bigger and bigger, what happened to the function? The output of the function is getting closer and closer to a horizontal line. Okay. If this is the case, then we will have the limit at infinity then. Okay. Of course, we could actually have the function is approaching from below the horizontal line or above the horizontal line, or maybe we could have the function is alternating, okay, about this horizontal line. In this case, we actually is always this situation right here, okay, then we have a horizontal asymptotes y equal to L then, okay, so this is the case. Of course, we could actually have the limit x approaching to negative infinity of f of x is also if equal to L, then in this case, you will see that the functions again, as x getting bigger and bigger in the negative side, okay, then the function is getting closer and closer to this horizontal line right here. Okay, then we will have the, again, horizontal asymptotes. Okay. Then definition number 3 is actually talk about this. The line y equal to L is called a horizontal asymptote of the curve y equal to f of x if either the limit x approaching to infinity of f of x equal to L or the limit x approaching to negative infinity of f of x equal to L then. Okay. Okay, so then now let us check it out, this problem right here. I have a function g. In this case, I would like to state the following. Okay, now let us look at the first one. So you will see that if the limit x approaching to infinity, as x getting bigger and bigger, of the function g of x, then look at this. You will see that what happened to the output. You see that means the functions is actually getting closer and closer to this line. Okay, y equal to 2. So my answer will be equal to 2 then. Okay. Okay. Then now it is your turn. Now go ahead and try to see if you could finish the rest of the problem now. Okay. Okay. Then now, as x approaching to negative infinity, then the functions is getting closer and closer to negative 1, right? Y equal to negative 1. The limit x approaching to 0, 0 is this line right here, then of g of x, the output is go to negative infinity. And now has x approaching to 2, 2 is here. From the left, so let's go to negative infinity. And from the right, let's go to infinity. Okay, so then now I would like to find the equation of the asymptotes. Okay, I know that if I have the limit x approaching to negative infinity or positive infinity, we talk about the horizontal asymptotes. So therefore, in this case, I will have the horizontal asymptotes, y equal to 2, and also y equal to -1. Okay. Now remember, it must be an equations. So don't just write down 2 or -1. Okay. It must be y equal to 2 or y equal to -1. And I know that if a limit x approaching to a number and the output is positive or negative infinity, that means we have a vertical asymptotes. And in this case, I will have the vertical asymptotes, x is equal to 0, and also x is equal to 2 then. Okay, right. Okay, right. Okay, so now then let us look at the following two example. Is related to a sketch. Okay, the graph of the example then. Okay, okay. So now let us look at number 2. So we have some conditions. Okay, let us look at the condition. What do we have? Okay, so I have the limit x approaching to 2 of f of x equal to infinity. Okay, so once I see that the limit x approaching to a number and the output is infinity or negative infinity, right away I know that is related to a vertical asymptotes then. Okay, so I will have vertical asymptote x is equal to 2. Okay, and x is equal to -2. And then to this one, if the limit, oh, this is actually is, okay, it's the same as the second condition, right? We will have the vertical asymptotes at x equal to 2, -2. And then to this one, we have x approaching to negative infinity or positive infinity is related to the horizontal asymptote. So I will have the horizontal asymptote is y equal to 0 then. Okay. And then of course, to this one right here is actually is telling me that I have a point on the curve. Okay, it's 0, 0. Okay. Okay, so then let's see how do we actually graph this then. Okay. So first, again, I would like to draw a okay, x-axis and the y-axis, right? And of course, we could actually have put down some scale. Mm-hmm. Okay. Then have 1, 2, -1, -2. Okay. Okay, so then now we will have a vertical asymptotes at x equal to 2. At x equal to -2. And then we also have the horizontal asymptotes is y equal to 0. Okay. Then now, let us try to analyze the problem then. X approaching to 2 of f of x is go to infinity. So therefore, in this case right here, I actually have this is go to, from the left and from the right, is go to infinity. X approaching to 2 from the right-hand side is go to infinity. And the left-hand side go to negative infinity. Okay. Then we have the horizontal asymptote here. Now, one thing about this is I know that in the long run, then what happened to the function? The function is getting closer and closer to the y equal to 0, but again, you will see that the function is, okay, it's getting closer and closer to y equal to 0. Same thing here. Okay. And now I have to look at the situation, right? In between -2 and 2. So I know that I have a point is 0, 0. The function will go for this point. Then now I need to connect this side to this side. Well, that's it then. Okay. Okay. Now, before I move on, I would like to talk about how do we actually find the possible functions, okay, to this graph then. Okay. So if you remember back to p-calculus, we talk about this. This graph right here is kind of like a rational functions. So how do we actually create a rational functions? Then here is the rule of thumb. Then to the rational functions, then the numerator is related to the x-intercept, and the denominator is related to the vertical asymptotes. Okay, and of course we always have a scratch factor. Okay, and it tell us that how stretched it is. Okay, or just a number. Okay, so then to work on this problem right here, we know that to the x-intercept, we have x equal to 0 because it just touched the x-axis. So therefore, in this case, I have the multiplicity is equal to 2. Multiplicity meaning the power of the fractions, okay, the factor here. Okay, and we also have the vertical asymptotes is x equal to -2 and x equal to 2. Okay, then now you will see that to the x equal to -2, this graph is look like this. Okay, so you will see that this is kind of like look like 1 over x, right? So meaning what, to this one, the power of this factor is 1, the multiplicity is 1. However, to x equal to 2, to this one is look like something like this. That means the graph is look like 1 over x squared then. So therefore, in this case, the power of this factor is it will be 2 then. Okay, so this is related to the multiplicity. Okay. Okay, so therefore, in this case, this function right here, I will write down is x squared, and then this one x minus 2, then I convert it into, this factor will be x plus 2 to the power of 1, and then this one will be x minus 2 to the power of 2 then. Okay, yes. So if you want to review, then go back to the your p-calculus textbook then. Okay, okay, then now it is your turn. Go ahead and try to work on number 3. Okay, now one thing about this is when the problem tell you that f is even, so what does this mean? Now you have to understand that to the even functions, if you have half of the graph is actually look like this, okay, then if it is even functions, that means what you will have, it is symmetric with respect to the y-axis. Okay, so basically this is is an even functions then. For example, like x squared, right? F of x equal to x squared, then you will see that the graph is look like this. Okay, then of course if it is odd, like x to the power 3, then it is symmetric with respect to the origin then. Okay, like this. Okay, so this is the odd function with respect to the origin. Even functions is with respect to the y-axis then. Okay, okay, so then this actually give you a hint to do number 3. Okay. Okay, so then let us look at number 3. So again, I would like to find the givens now. So this tell me that I have a vertical asymptotes at x equal to 3, and to this one I have a horizontal asymptotes is y equal to 2. Okay. And then, of course, I have points, right? And f is even, right? Okay. Then now, let's see. Okay, so then let us put some scale on the graph. Okay, so I have 1, 2, 3, 1, 2. Okay. Okay, so then, so I will have a vertical asymptotes at x equal to 3. I have horizontal asymptotes y equal to 2. Okay. Okay. Then now, for x approaching to 3 of f of x go to negative infinity. So therefore, again, in this case, I will have something like this. And I have a point is 0, 0. Okay. Okay, so now what I need to do is we are going to put, now consider that again, we will put a mirror on the y-axis then. Then you will see that we have a symmetrical graph, right? So kind of like we have this one, just copy it, okay? Then, of course, I will have 1, 2, negative 3 here. So I will have a vertical asymptotes at x equal to negative 3. And also my horizontal asymptotes is y equal to 2. Okay. And now, okay. And of course, this is actually like this one. That's it. So then this is actually is the idea. How do we actually, again, sketch the graph, okay, from the conditions. Okay, now the next 2 examples, or maybe 3, is actually related to how do we find the limit as x approaching to positive or negative infinity now. Okay, so now to this one right here, then let's see, how do we do this? We are going to use these 2 conditions right here. If we take the limit x approaching to infinity of 1 over x to the power of r, where r is a rational numbers, okay, positive, then it must be equal to 0. Okay. Now again, if you know that if I have 1 over 10 is about 0.1, 1 over 100 is actually is 0.01. Do you see that when the number in the denominator is getting bigger and bigger, what happened to the output? The output is getting closer and closer to 0. This is exactly the idea here. Same thing as the limit x approaching to negative infinity of 1 over x to the r, and then it is also equal to 0 then. Okay, so this is actually the idea. Now, the following 2 or 3 examples, then we are going to use this technique. Okay, the 3 number 5 to help us to do this problem. Now here is something that we have to know what we need to do then. In order to use these properties for finding the limit of rational functions as x approaching to positive or negative infinity, we first divide each term of the numerator and the denominator but by the highest powers of x present in the denominator. So we need to look at the power of the denominator then, and then we determine the limit of the resulting expressions. Okay, so then let us look at this. Now you will see that to this one, the power in the denominator is, actually I look at the denominator, is x to the power 3. So what do I need to do is, I'm going to multiply top and bottom by 1 over x to the power 3 then. Okay. Always look at the power in the denominator. Then now, what do we need to do is, we are going to simplify this then. Okay. So I will have 4x to the power 3 over x to the power 3 plus 6x squared over x to the power 3 minus 2 over x to the power 3 all over 2x to the cube x to the power 3 minus 4x plus 5. Okay, like this. And then now, the next step, of course, we are going to simplify them. Okay. Then I will have 4 plus 6 over x minus 2 over x to the power 3 all over 2 minus 4 over x squared plus 5 over x to the power 3. Okay. Then now, we are going to take the limit to each term. Okay. Then you will see that, oh, actually it's this one. So meaning this one, this go to 0, this go to 0, this go to 0, this go to 0. After we take the limit, then the answer that I have, it will be 4 over 2 then, which is equal to 2. Okay. Okay. So what does this mean? Okay. It's actually tell us that, now again, this is the result. This is the answer that we have. Okay. So this is the answer. But the result is actually tell me that to this expression 4x to the power 3 plus 6x squared minus 2 over 2x to the power 3 minus 4x plus 5, okay? For example, if this is the function right here, it's actually, this function has horizontal asymptotes at y equal to 2 then, okay? This is the idea. Okay, so now it is your turn to actually to work on number 5, okay? Now to this number 5, you have to understand that when we try to have 1 over square root of x squared, then remember to this one right here, basically square root of x squared is the absolute value of x, okay? So remember this, okay? And you could actually work it out this problem then. Okay, so let's see how do we actually take care of this problem. Okay. So you will see that to this one, the highest degree is actually the square root of x squared. Okay. So I will have 2x multiplied to 1 over square root of x squared and x squared plus 1 multiplied to 1 over square root of x squared. Okay. Then now, to the denominator, I will be able to combine them together. Okay. And then to the numerator, then we know that this is the absolute value of x. Okay. Now, to the absolute value of x, we know that it is equal to negative x, has x is less than 0, and then you go to positive x, has x is greater than or equal to 0. Okay. So, therefore, in this case right here, this one, sin x is approaching to negative infinity, meaning what? This absolute value of x is equal to negative x then. Okay. And then of course the denominator we could actually simplify. So I will have x squared over x squared plus 1 over x squared. Okay. And now I will have the limit x approaching to negative infinity of negative 2 over square root of 1 plus 1 over x squared. Okay. And again, if we take the limit, then we know that this go to 0, then the answer will be negative 2 over square root of 1. So my answer will be negative 2. Okay. Yeah. Okay. Then now, let's look at the next two problems now. Okay. So now to the next two problems. Let's see how do we use calculus to analyze these two problems right here. Okay. Now, of course, to this function right here, we know that one thing about this is, as x go to negative or positive infinity, we always look at the leading term, right? And then to determine the behavior. And then how do we actually use calculus to do this? Okay, to show that this is what we are looking for, or this is the answer. Okay, and what we need to do here is we could actually take out the x to the fifth, and then let's see what do we have. Then of course I will have 1 over x plus 1 then. Okay. And now you will see that what happened here when this go to 0, or when we take the limit, right? This term go to 0, then what do we have? We just have the limit x approaching to negative infinity to x to the power 5. Okay. Times 1, right? So then if you look at the graph of x to the fifth, then we know that the graph is look like this. Okay, so therefore the answer in this case, it will be negative infinity. Okay, so that's it. So this is the idea. Okay. Okay, so to number 7, how do we approach this problem right here? Okay, now one thing about this is, if you plug it in infinity to the problem here, then we will have infinity squared plus 2 times infinity, meaning what? This is infinity. And then we minus infinity. Now, in this case, we have infinity minus infinity. Wow, it seems that is the answer equal to 0, okay? But actually, this is not the case, okay? Now, when we have the expression go to infinity, we could not just use this, the simple addition and subtraction rule to do the problems, okay? So therefore, in this case, how do we actually approach this problem? Now, remember, this expression right here, I have a square root of x squared plus 2x minus x. So what I'm going to do here is, I'm going to multiply this by the conjugate pair, square root of x squared plus 2x plus x. Okay, this is what we need to do. Work with the conjugate pair. Okay, now try to pause the video and then work on number 7 to see if you know how to do this. Okay. Okay. Then I have the limit x approaching to infinity. Of course, now remember the conjugate pair. A plus b times a minus b is a squared minus b squared, right? Okay. So meaning in this case, I will have x squared plus 2x minus x squared. Okay. And of course, to this one, I will have x squared plus 2x plus x then. And now these two cancel out. I have 2x all over square root of x squared plus 2x plus x. Okay. And now I'm going to multiply top and bottom by 1 over square root of x squared. Okay. So again, remember square root of x squared equal to absolute value of x. However, this one, since x go to infinity, absolute value of x is just equal to x then. Okay. So I will have the limit x approaching to infinity of 2x over x all over x squared plus 2x over x squared plus x over x. Okay. So I will have 2 all over square root of 1 plus 2 over x plus 1. Then I will have, remember this go to 0. So I have 2 over square root of 1 plus 1. So it is 2 over 2. Okay. So my answer is equal to 1. Okay. Okay, so then now let us work on the last one. Now the last one is actually really similar to what we did it before, just like these two. Okay, number 2 and number 3. But one thing about this to the last one, I would like you to find a formula, okay, to work it out after you graph it then. Okay. Okay, so then let's see. Again, we know that in this case we have a horizontal asymptotes, y is equal to 0, and we have a vertical asymptotes, x is equal to 0. We also have another vertical asymptotes, x is equal to 3. Okay, and then the last one we have a point to 0. Okay, so this is what we know. Okay, then now let's try to graph this first then. Okay. One, 2, 3. Okay. Vertical asymptotes as x equal to 3 and x equal to 0, and horizontal asymptotes is y equal to 0, and then we have the point to 0. Okay, then now let us analyze it. The limit x approaching to 0 of f of x is equal to negative infinity. X approaching to 3 from the left hand side is go to infinity. From the right hand side is go to negative infinity. So then, okay, and I know that I need to connect from here to here. And the last one. Okay, oh, that's it. So this is actually is my f function. Okay. Okay, so then now the second step is we need to find a formula. Okay. So we know that the x-intercept is x is equal to 2, the multiplicity is 1, and to the vertical asymptotes, x is equal to 0, multiplicity is 2, and x is equal to 3, the multiplicity is 1. Again, the reason is this one, the graph look like 1 over x. Okay, so therefore it is 1 right here. To this one, the graph look like 1 over x squared, right? Okay, so this is the reason. Okay, then now I have f of x is equal to a times x minus 2 all over x squared x minus 3. Okay. Again, is the x-axis, x-intercept over the vertical asymptotes. And then this a right here is actually is a stress factor, right? Or to determine if it's positive or negative. Okay. Then now, let us look at the first situations. If a is equal to positive 1, then I will have f of x is equal to x minus 2 over x squared x minus 3. Okay, so let us test the limit. Okay, so remember a, it could be positive or negative 1. Okay, then I have x approaching to 0 from the left hand side of x minus 2 over x squared x minus 3. Okay, then now let's see. If I evaluate, I have negative 2 over 0. Okay, so therefore again the answer is could be positive or negative infinity. This is exactly what we are looking for. And then now 0, we are approaching from this side. Then how about we choose negative 0.1, right? So actually to work out. Then you will see that what happened here. I know that if I plug it in 0, then the numerator is always negative. And then how about the denominator? If I plug it in negative 0.1, then I will have this one is positive, and then negative 0.1 is negative 0.1 minus 3 is negative. So it's turned out that the whole thing is actually is give me a positive infinity. Okay. However, f has the limit x approaching to 0 from the f of x, okay, from the left-hand side of f of x is negative infinity, okay? So this is actually contradicts. So therefore, in this case, a cannot be positive 1 then, okay? Then I will have f of x is negative x minus 2 over x squared x minus 3 then. This is a formula, okay? Okay, so that's it. Okay, so now in this section right here, we talk about the infinity, the limit at infinity, which is talk about the horizontal asymptotes. Okay, thank you.